All right, welcome to the Explainer. Today, we're going to pull back the curtain on something that honestly powers just about everything you do online. We're talking streaming movies, collaborating on work docs, you name it. It's called distributed computing, and it's time we really understood how it all works. So let's just start with a simple question to get our heads in the right space. If you have a massive, complicated problem to solve, what's better? One single, super powerful computer doing all the heavy lifting, or a whole team of smaller computers all working together? That question, well, it's pretty much at the heart of everything we're talking about today. And yeah, distributed computing has a very clear answer to that question: teamwork. It's a system where all the work, the processing, the storage, everything is spread out across a whole network of devices. So instead of having one hero computer that can be a single point of failure, you've got a whole team collaborating. And that means if one device goes down, the whole system doesn't come crashing down with it. This visual right here just nails the difference, doesn't it? On the left, you've got that traditional, centralized model. One big brain trying to solve a huge puzzle all by itself. You can see how it could get overwhelmed, right? But then on the right, you see the distributed model. It's a team of brains, and each one is just tackling a small piece of that puzzle. Together, they get it done faster and way more reliably. It's a totally different way of thinking. Okay, so we get it. It's about teamwork. But what does that team of computers actually look like? Let's start with the absolute foundation and really define what makes a system distributed. The easiest way to think about it is really just like a group project, but for computers. Imagine a team where everyone gets a part of the assignment. They're all communicating, they're sharing information, and then they combine their work to create that final product. And here's the key part. There is no single boss computer telling all the others what to do. So if it's a team, what are the actual building blocks that make it all work together? In this next part, let's look at the key components, the rules of the road, if you will, that let these systems work so well. So every distributed system is basically built on three pillars. First, you've got the devices themselves. These are the individual computers or nodes. Then you obviously need a network. That's the backbone, the communication lines that let all those devices talk to each other. And third, you gotta have some kind of resource management to decide who gets to use what and when. And these characteristics are what give the system its unique personality. We know the work is spread out, and often it's what we call a peer-to-peer setup, which just means any device can both ask for help and provide help. But this last point, this is so important. This scale horizontally. What that means is when you need more power, you don't have to replace your machine with a bigger, way more expensive one. Nope. You just add another computer to the team. It's so much more flexible and, a lot of the time, way cheaper to grow. Now, this all sounds pretty amazing, I know, but like with any powerful technology, it's not all sunshine and roses. There's always a trade-off. So in this section, let's get real and take an honest look at both the good and the bad of this approach. The upsides are huge, right? You get incredible scalability, you get that reliability, and a ton of flexibility. But there are trade-offs. Managing a whole team of computers is just naturally more complex than managing one. More connection points also mean more potential security risks, and sometimes the time it takes for all these devices to talk to each other can actually slow things down compared to one single perfectly optimized machine. But for a lot of people, the reliability is the absolute killer feature. This quote here really nails it. Distributed systems can continue to operate even if one device or system fails. Think about that. If one member of the team goes offline, the rest of them just pick up the slack. The whole service doesn't crash. That resilience is exactly why your favorite streaming service basically never goes down. So, we've talked about the what and the how, but what about the where? In this last section, we're going to look at where you actually bump into distributed computing in your daily life. And I promise you, it's a lot closer than you think. The truth is, you are using distributed systems every single day. When you're working with a team on Google Docs or you're binging a show on Netflix, you are tapping into a massive distributed team of servers. It's also the foundation for things like file sharing networks and the whole way modern apps are built now, using something called a microservices architecture. That's basically where an app is broken down into a collection of tiny, independent services that all talk to each other. So if there's one main takeaway, it's this. Distributed computing isn't some weird academic idea. It is the invisible architecture that holds up the internet you use constantly. It's the huge, hidden part of the iceberg that makes everything you see on the surface even possible. Okay, so to wrap it all up, let's hit the three big takeaways. If you remember anything, remember these. First, it's about teamwork. Spreading the load makes the whole system way stronger. Second, it's about resilience. That teamwork is what gives you that shield of reliability for the services you depend on. And finally, it's about balance. You're always weighing those amazing benefits against the real challenges of complexity and security. And that leaves us with one final, pretty big question to think about. As our need for data just explodes and our world gets more and more connected, are we heading for a future where just everything is built on a distributed model? And what does that mean for how we build, secure, and manage our digital lives? Thanks for tuning in.